Hello guys, we are going to continue with the second video for the carboxylic acid and the chemical properties. So this is the mind map showing the chemical reactions that can be derived for the chemical properties of carboxylic acid. As you can see, there are so many ways of preparing carboxylic acid, starting from alkene. You can use a hot concentrated acidified potassium manganate to cause the carbon cleavage and form carboxylic acid. You can also making use of the haloalkane to synthesis as a Grignard reagent followed by the carbon dioxide and acidic hydrolysis. Or you can also react with ethanolic potassium cyanide under reflux to form a propanenitrile and followed by acidic hydrolysis. And then you can also react by oxidizing propan-1O to become carboxylic acid. Or you can also use aldehyde to oxidize to become carboxylic acid. Now, there is also other alternative methods. So since carboxylic acids can form any other carboxylic acid derivative, in other words, other carboxylic acid derivative can also form back to carboxylic acid via various ways of the hydrolysis, which we will look into one by one in each of the chapter later. So this is the mind map for the chemical properties of the carboxylic acid, so hope that you'll be able to understand. So let's have a look at the summarized tables for the chemical properties of carboxylic acid. So these are the series of the chemical preparations starting from the alkene where I mentioned just now. You have to use the oxidation cleavage of C+1C by using hot concentrated acidified potassium manganate under reflux. So this is a general equation for it. And then you can also use Grignard reagent followed by carbon dioxide and hydrolysis, so under reflux, so to form this carboxylic acid. You can also undergo hydrolysis of alkyl nitrile when you use dilute HCl H2SO4 to form carboxylic acid. Oxidations of the aldehyde and primary alcohols will also give carboxylic acids, especially when under reflux. And various ways of hydrolysis carboxylic acid derivative by using WHCl water. So for acyl chloride, if you want to form back carboxylic acid, you use water. For ester and also amide, you use acidic hydrolysis to form back the carboxylic acid respectively. So these are the way of how we prepare carboxylic acid. Now these are the series of the chemical properties or chemical reactions that we are going to have a look for the carboxylic acid. So since carboxylic acid is an acid, so it can react with base or metals or metal carbonate to form various products of salt and side product. So when carboxylic acid react with metal, you form salt plus hydrogen. When carboxylic acid react with metal hydroxide, you form salt plus water. When carboxylic acid react with metal carbonate, you form salt plus water plus carbon dioxide. Now, carboxylic acid can also be reduced by using a strong reducing agent to form two different classes of the alcohol. So to form alcohol back, primary alcohol back. So later we are going to have a look at the reactions. Carboxylic acid can also be used to esterificate to form ester. It can also undergo acylations to form acyl chloride. And finally, form amide when we add with concentrated ammonia under reflux to form a primary amide. So these are the summarized table of the chemical properties of the carboxylic acid. So without hesitation, let's have a look one by one for all the reactions that I've prepared for you. So a reaction of carboxylic acid with metal hydroxide and metal carbonate. So since carboxylic acid possess almost all chemical properties, which are reaction with metal to produce hydrogen, reaction with metal hydroxide to produce salt and water, and reaction with metal carbonate to produce salt and water and carbon dioxide. So these are the summarized equations inside the tables that I highlighted for you in order for you to know how to balance it. And in here, all these equations must be right in a balanced manner because these are all simple neutralization reactions. So especially for the reaction between carboxylic acids and metal carbonate is one of the ways to distinguish carboxylic acid with other functioning group. So other than used to distinguish other functioning group, this reaction is also used to compare the strength of carboxylic acid, especially with that alcohol and phenol. So table here I summarize for you what are the possibility of the reactions when you react alkyl alcohol, phenol, and also carboxylic acid with metal hydroxide and metal carbonate. So you can see alkyl alcohol can only react with metal, phenol can only react with metal and metal hydroxide, but carboxylic acid can react with all metal, metal hydroxide, and metal carbonate. So in here you can see that the acidity strength actually increased from alkyl alcohol to phenol to carboxylic acid. So you should most of the time to compare the acidity in between carboxylic acid and other substances, we will preferably use metal carbonate as the methods. So these are a few examples of the equations for the reactions. So you can see from here, because this is carboxylic acid, so it can react with metal to form salt plus hydrogen. It can react with metal hydroxide to form salt plus water. And also you can react with metal carbonate to form salt plus hydrogen plus carbon dioxide. So all of them, the equations here are balanced for you. So hopefully you'll be able to understand on the way of how to react them. So this is the first chemical properties of carboxylic acid. Let's have a look at the second chemical properties of carboxylic acid, which is the reduction of the carboxylic acid. So by using a strong reducing agent such as lithium tetrahydroaluminate followed by acidic hydrolysis under reflux, carboxylic acid can be reduced to become primary alcohol. So in this process, aldehyde is formed as an intermediate, but it cannot be isolated because it's easily reduced to alcohol, and it is more easier to reduce alcohol compared to carboxylic acids. So these are the mechanism for the reactions in here. So you can see, but as I said earlier, the mechanism is not important. So this is just a knowledge for you to know how does this carboxylic acids works in here. Okay. Okay, so this is how does the carboxylic acid works. Okay, so below I shows you reactions in between carboxylic acids with lithium tetrahydroaluminate. So these are the series of example of equation when ethanoic acid react with the lithium tetrahydroaluminate. So you form alcohol plus hydrogen. And then if you have a dioic acid, you react with lithium aluminium tetrahydrogen, so you form a diol in here. Now if you have an alkene carboxylic acid, so the C double bond C will remain there, but it will still reduce to become a primary alcohol. And if you have both aldehyde and also benzoic acid, benzaldehyde and benzoic acid in the functioning group, you all reduce to become a primary alcohol. So of course this is just examples of the reactions. It may be varies depending on the conditions in here. Okay, so this is the reduction reactions of the carboxylic acid to become primary alcohol. So the third reactions of the carboxylic acid that we're going to see in here is esterification of carboxylic acid. So Fischer esterification converts carboxylic acid and alcohol directly to become ester by an acid catalyzed nucleophilic acyl substitution. So the net reaction is replacement of the acyl group OH to the OR, which is the alkoxide groups of the alcohol. So this reaction is called as a condensation reaction since water molecule is removed as a side product. So general equation for the reactions are described in here, where you have RCO CH2OH, where you have R double naught COOH. So catalyzed under concentrated sulfuric acid and reflux, you form RCO CH2R plus water as a side product. So here are the mechanisms for the reactions in between the esterifications of the carboxylic acid. As I told you, this mechanism is just references for you to understand on how this reaction works. So the rest of it actually is more or less the same. Okay. So from the reaction scheme, the formation of ester involves OH, which is removed from the carboxylic acid, while H is removed from an alcohol. Though the naming of ester works in the way that the alkyl group from the alcohol, which are alkanoate is from the carboxylic acid. So this is how we are going to name this ester. So we are going to call as alkyl alkanoate. Okay. So for example, if you have ethanol, react with ethanoic acid, so you form ethyl ethanoate plus water. If propan-1-O react with butanoic acid, you form propyl butanoate plus water. If you have butan-1-O react with propanoic acid, you form butyl propanoate. Ethanol react with propanoic acid to form ethyl propanoate plus water. So these are a few examples of the esterifications reaction. So more of it we are going to have a look later when we come into ester later. Fourth reactions of the carboxylic acid is the acylation of carboxylic acid. So since acyl chloride are the most reactive of acid derivative, we must use a special reagent to prepare them. So for the acylations, it is either we use phosphorus pentachloride or thionyl chloride for the reactions. So both reactions will produce acyl chloride and HCl as a side product. So you observe this HCl in here as a white film. Okay. So general equation for the reactions are as follows. If you have RCOH plus PCl5, you form RCOCl plus POCl3 plus HCl. RCOH plus SOCl2 give RCOCl plus SO2 plus HCl. So these reactions all involve nucleophilic additional elimination by a chloride ion or the highly reactive intermediate, a protonated acyl chlorosulfide, a protonated acyl chlorosulfide, or a protonated acyl chlorophosphate. So this intermediate contain even better acyl leaving group compared to the acyl chloride products in here. So in another word, they are ready to be eliminated anytime. Okay. Okay, so these are the examples of the equation for reaction. So as you can see in here, if you react carboxylic acid with PCl5, you form CH3, CH2, COCl. If you react 2-methyl propanoic acid, you form 2-methyl propanoic chloride. If you react 3-methyl butanoic acid, you form 3-methyl butanoyl chloride. And if you react benzoic acid with PCl5, you form benzoyl chloride. Okay, so all of them will eventually form HCl, which you can observe as a white film in here. Okay. Okay, and last but not least, you have the formation of the amide from carboxylic acid. So carboxylic acid react with concentrated ammonia to form ammonium salt. So due to the low reactivity of the carboxylic ions toward nucleophilic additional elimination, further reaction does not usually take place in the aqueous solution. However, if we evaporate the water, the subsequent heated by the dry salt, dehydration produces an amide. So this is the general equation for the reaction where we have carboxylic acid react with concentrated ammonia to form amide plus water. However, this is a poor method to prepare as amide because a much better method is by converting the acid into acyl chloride and then treated with ammonia or amine to prepare a different class of the amide. Still, this method is still producible and it will still form a primary amide if the conditions is fulfilled. Okay, so some of the examples of the reactions are shown in the table below. So all of them will eventually form a primary amide and water is formed as a side product in these reactions. Okay. Okay, so with that, that is all for the chemical properties that I would like to introduce in the second video. So I'm going to continue more on later in the third video. Okay, thank you.